we have two other mixture type problems to solve. This one goes to the wonderful world of Star Trek, specifically Voyager. While you're reading the problem, I'll get ready to highlight the sentence that will tell us where our variables are. Again, notice the wonderful question mark. Those are going to become your friends. And we even have a how much, so those are two wonderful things. How much of each must he buy to make a mixture that sells for $7.20 a pound? So the real part of this that we're interested in is the how much of each must he buy. If I were looking at variables, I don't really care why he's buying them. Not for my variables, for my equations, but not for my variables. So, each means I've got two different things to look for. Let's find out what they are. I have two types of coffee selling for $6 and $8 a pound each. So when we go to define our variables, again, I don't really have very good descriptor words. I could say 6 and 8, so S and E, but that's not very helpful. So I'll call them X and Y again. Now, how much of each? This much, I could have asked this in a different way. I could have put the units in this phrase, and that would have said how many pounds of each must he buy. So I know that this is going to be measured in pounds, and I would say number of pounds of, let's call this one the $6 per pound coffee. And so Y would be the number of pounds of the $8 per pound coffee. And now we're ready to move on to our equations. So for our equations, remember we have two scenarios going on. We're going to have coffee, a coffee equation, and then a cost equation. That's completely illegible. Try that again. So, if I want to know how many total pounds of coffee I have, I look and see that Neelix has a 50 pound vat, so 50 is going to equal the number of pounds of the $6 coffee plus the number of pounds of the $8 coffee. And then for my cost equation, how much per pound does the $6 per pound coffee cost? Kind of gave it away. $6 for each pound plus $8 for each pound of that one should give me, I know I've got 50 pounds total, but how much will it cost per pound? Well, that's where the $7.20 comes in. $7.20 per pound. And that's where I find my two equations. If you can identify the two types of equations you're looking for, it makes it a little bit more straightforward. So now we're ready to solve. Again, I like substitution. If you look at this equation, 50 equals x plus y, I like substitution. That was weird. Substitution. Coefficient of 1. And in the other equation, I have my 6x plus my 8y is going to equal, I'm doing this in my head, bear with me, should equal, is that $360? Okay, this is where I write it down, and then I'm going to go grab my calculator and check, so hang on. And I was right, it is 360. Sometimes I can do decimals in my head, sometimes I cannot. So now I get to pick which of my two variables to isolate for our substitution. I'm going to take my 50 equals x plus y and isolate, pick a variable, any variable, isolate y. So y will equal 50 minus x. And I'm going to plug that piece into the y place in my other equation. So I get 360 equals 6x plus 8 times 50 minus x. Now I'm ready to solve this equation for x. 360 equals 6x plus now 8 times 50, 400, minus 8x. I'm going to subtract 400 both sides and I get negative 40. When I combine these two, I get a negative 2x. Divide both sides by negative 2 and I get 20 equals x. If I plug 20 equals x into my 50 equals x plus y, I end up with that y equals 30. So now we need to check, and I'll do that in a different color. 360 should equal 6 times 20 plus 8 times 30. So 360 should equal 6 times 20 is 120, 8 times 30 is 240, and that in fact equals 360. So Neelix needs 20 pounds of the $6 coffee and 30 pounds of the $8 coffee. And luckily, your teacher's probably not that picky about spelling. I have one more mixture type equation for you. This one's a little bit different from the others in how we're setting up the equations. So go ahead and take a quick look. Once more, I'll get ready to highlight what our variables are. So our question is, how much did he invest in each fund? If blah, 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 blah. And we'll get to the blah, blah here in a minute. But I'm only interested at this point in verifying and confirming what my variables are. Each fund and the how much is going to be dollars. So it's helpful to know, okay, the two things I'm looking for are types of funds, and the how much I'm looking for, the quantity I'm measuring, is going to be dollars. So for our variables, I have two different investment rates, so those are going to be my two funds. Again, no nice descriptors, so I'll do X and Y. Erase those because those will come back in a second. So X will be the number of dollars invested at 6% interest, and Y would be the number of dollars invested at 12% interest. Now, typically with these interest problems, we're not going to tell you what his overall interest on his investment was at the end of the year. So that's what makes the equations a little bit different than what we've had before. So to figure out our equations, first I want to name them. We're going to have a total invested, and then we're going to have an interest equation. The total invested is just like the total amount of coffee or the total amount of solution. That's going to be my x plus y equals, okay, Yoda, how much did you invest? $1,000. Again, I do not know Star Wars currency. Now, the interest is where we pull in our percents. So 6% of x plus 12% of y. This is where we would normally multiply two things to get our last piece of our equation, but all I know is that I have $108 of total interest. So this entire thing is going to equal the 108. And now we can solve. So since there's no multiplying to do in that last equation, these interest equations are actually a little bit more straightforward. There's one fewer step to do for this type of problem than there have been for the other ones. So to solve, I'm going to look at my two equations. X plus y equals 1,000 and 0.06x plus 0.12y equals 108. Now, again, you could choose substitution or elimination. We've done a lot of substitution lately, and I know that the next few slides will also be substitution, so we are going to do elimination. It's not going to be a terribly cumbersome elimination, though, so we will do elimination. And I want to eliminate x. So what that's going to look like is I'm going to multiply my top equation by negative 0.06. So what I will get is a negative 0.06x minus 0.06y is going to equal, now this is going to be a little bit of a trick. You could do it in your calculator. I'm going to do it by hand. I know it's going to be negative, and this is going to be, move my decimal twice. Should just give me 60. And we'll find out if I'm right here in a moment. So these eliminate, and I get 0.06y equals, now 108 minus 60, there's an 8, 48. Y will equal, if I divide 48 just by regular 6, I'm going to get 8. If I divide 48 by 60, I'm going to get actually, sorry, by 0.06, I'm going to get 800 out of that. So now that I have y equals 800, I need to figure out what my x is. So x plus 800 should equal 1,000, which means x should equal 200. Now to check this, I'm going to plug the 200 and the 800 into the other equation. 0.06 times 200 plus 0.12 times 800 should equal 108. 0.06 times 200 should give me, doing this in my head again, it's always dangerous. I'm going to do this wrong. So I'm going to bring up my calculator again. We'll pause while I do that. Actually, I'll just do it here. You can see. That's fine. So 0.06 times 200 plus 0.12 times 800. Make sure it gets all of those pieces, and when I hit enter, I should get the 108, and I do. And that gives me a smiley face. So we say Yoda invested $200 at 6% interest and $800 at 12% interest. And that's all we need to say. We're at 15 minutes, so I'm going to pause and do the next problems on another video.